All right, so we're going to look at the rationals review here. There's 25 problems on here, so here we roll. I'm going to go fast. You can always slow it down or do whatever you need. So I'm going to look at number one here. It says simplify the fraction completely. If the fraction does not simplify, write the fraction in its current form. Um, so first of all, I'm looking at this problem right here, and I actually don't think that there's anything that reduces, so I'm just going to leave it. It's good right there. The top and bottom are not divisible by any numbers. I'm going to try the next one to see if I can make this one simpler. So if I look at this one, number two, I got 32 over 12x to the fourth. Um, I think that the numbers, if I think about these two, they're both divisible by 4. So 32 divided by 4 and 12 divided by 4. This would give me 8. And then on the bottom, this would give me 3. And then they both have x in them. This has 1x, and then this is x to the fourth. So I could really think of this as like x over x to the fourth. So one of them is going to cancel, so we'll have 3 of them left over on the bottom. So this would be my final answer. Look here at number 3. How to simplify this one. Looking for greatest common factor. If I look at the numbers, they're both divisible by 2. So if I do that, I'll have 3 over 7. And then there's only x's on the bottom, so it'll just be x to the fourth. I can't do anything else with that, so this one is done. Number 4, it says perform the operation and simplify the answer fully. So this should scare people because it has a fraction over a fraction. If you do that, you actually just copy down the first fraction, and then you can multiply the bottom fraction flipped. So if I flip this, the bottom one gets flipped. This will be 5x to the third over 6. Well, now I can start trying to see if I can cancel some stuff out. So one thing I can see is that if I look at numbers, 5 goes into both of these. So if I divide 5 on the top, this will just be 1. If I do 5 divided by 5, sorry. And if I did 10 divided by 5, this will turn into 2. And I can also see that 3 and 6 are both divisible by 3. So when I do that, I'm just going to kind of clean this up here. I'm going to have 3 divided by 3 is just 1. 5 divided by 5 is 1. Then I have x to the third times x to the third, which is really x to the sixth. And on the bottom, I have 10 divided by 5, which we said was 2, and 6 divided by 3, which is 2. So at the very end, I'm going to do 1 times x to the 6th is just x to the 6th, and 2 times 2 is 4. All right, so now I'm going to go jump up here to number 5, and it says simplify this answer fully. So I'm going to try to look for things that'll cancel on the top and bottom. So there's 1x here. And then down here, I can really think of x squared. I'm just going to rewrite that as x times x. I think that'll make it simpler. So then one of these x's and one of these x's would cancel. And then nothing else is going to cancel, so I'm just going to multiply everything. So this will just be 1 on top. And then 3 times 4 is 12 times x. So this will be 12x. If I look here, I have division. And when I have division, I can times and then flip the second one. So it's sort of like this fraction over fraction, because you could think of this as 3x to the third over 10 divided by that. They just put the division symbol instead of stacking them on top. So I'm going to rewrite this as x to the third over 5 times this one flipped. And when I do that, I'm going to see that there's a 5 here and a 5 here that would cancel. And that's all the things that are on the top and bottom that cancel. So x to the third times x squared is x to the fifth. And then there'll just be a 2 on the bottom. And that'll be my answer for number 6. If I look here, it says perform the following operation and express in simplest forms. So unfortunately, what I'm going to have to do is I'm going to have to factor a lot of these. So you guys know box and circle. So I'm going to do box and circle on this one, or this one I can do in my head, but if you can't, you should do box and circle. So I know I need two things that multiply to -6, but when you add them, they add up to 5. So I think it's +6 and -1. And then on the bottom here, I need them to multiply to 8. Be x times x. I need to multiply to 8, but add to -9. So I think I do -8 and -1. So that should work. And then on the other side, I'm just going to leave the x squared here. And then on the bottom, I see that they both have something that has a 3 in them. So I can rewrite this bottom part using greatest common factor as 3 times x plus 6. Now, once I've factored all of that out, I'm going to see if there's anything that will cancel. So I'm looking for things on the top that are on the bottom. So I got x plus 6 and an x plus 6. I have an x minus 1 and an x minus 1. So on the top, the only thing that's left is just the x squared. And then on the bottom, I'm just going to write it as 3 times x minus 8. Now, I don't know, but you could also write it, this would be totally fine, but it could also be written as 3x minus 24. But I like this answer better. All right, number 8. Perform the following operation and express it in simplest form. So if I look here at this, this is difference of squares. So if you factor this, it should be x plus 8, x minus 8. And if you're having trouble with that, take a look at the factoring section. Then I'm going to copy that x minus 8 on the bottom. Then here I see division. So I'm going to change that to multiply. And then I'm going to flip the second fraction because this is division. That's what we do. We flip it. So 3x goes on top. And then this part I'm going to need to factor. Now you could use box and circle. I'm doing it in my head. I'm thinking of two things that multiply to -24, but they add to 5. So I'm thinking plus 8 and minus 3, because I think 8 times -3 gives me -24, and then 8 plus -3 gives me +5. So now I'm just going to cancel things that are on the top and bottom. I've been using that pink color. So the x minus 8's go, the x plus 8's go. The only thing I'm left with is 3x on the top and x minus 3 on the bottom. All right, so that's the first 8 problems. Now we're going to go to number 9. More practice here. Again, I see division. So I know I'm going to be multiplying and then flipping. So I've already put that on the bottom there. But I just want to factor all this stuff out. So this first part is x plus 3. On the bottom here, this is difference of squares. So this will be x plus 3 times x minus 3. Then this part right here, which has to go on the top, I'm going to factor that. And I'm looking for two numbers that multiply to 18, but they add to -9. So I know one of them's got to be positive, and one of them, actually, no, that's wrong. Both of them have to be negative. Because a negative times a negative makes a positive, but then they'll add here. So I'm thinking -6 and -3. And that looks like that works. So now I'm just going to cancel things that are on the top and bottom, and the last part I have here is x minus 6 over x squared. Looking here, I'm going to factor again. This one just has multiply, so I don't need to flip. I'm just going to leave it alone. But I am going to factor everything. So this part on top should be x minus 2, x plus 1. And then I'll just copy the x plus 1 underneath. Then I have a times here. Then on the top, this I can pull a greatest common factor. I can take an x out. So if I take an x out, this should be x times x plus 3. And then the bottom, that's going to be, see, multiplying to -6 adds to a positive 1, so it should be +3 minus 2. And then now I'm going to get my pink one out and cancel stuff. So the x minus 2's cancel, the x plus 3's cancel, the x plus 1's cancel. So the only thing that's left is just x. All right, number 11. Combine the following fractions and express in fully reduced form. So in order to do this, I need common denominator. So what I'm going to do is I can multiply by 1, but I need the denominators to be the same. So right now, I'm going to multiply 9 by 8 over 8, because that's really just 1. So when I do that, 8 times 8x is going to give me 64x, and then 8 times 9 is 72. And then I have the plus sign in the middle, and then this one, I want it to be 72 on the bottom, so I'm going to times it by 9 over 9. And I can do that because 9 divided by 9 is just 1. So 9 times 9 is 81, and 8 times 9 is 72. So now you notice they both have common denominator, so I copy the denominator, and then the top will just be 64x plus 81. And this should be my final answer. And I'm going to jump over to number 12. So if we add or subtract, we have to have common denominators. Lucky thing here is the denominators are the same. So I just copy the denominator down. Now I'm just going to deal with the top. So -2 minus -2, and minus a minus is like plus. So it's really just going to be 0 over 3 or just 0. Going down to number 13. Minus here, so I need common denominator. Um, a lot of people will treat this and just want to do -1 on the bottom. You can't do that. This is a package. So what I'm going to do is I'm going to multiply this one by x minus 1 over x minus 1. And then this one over here, this one's going to get multiplied by x over x. And when I do that, put parentheses around here, when I do that, then you notice that the denominators, whoops, pink, are the same. So when I do that, I'm going to copy the denominator, which is just x times x minus 1. And then the tops, I'm going to have to clean up here a little bit. So this thing I'm going to have to multiply together. So x minus 1 times x plus 5, I'm going to do x times x is x squared. X times 5 is 5x. Minus 1 times x is minus x. And minus 1 times 5 is -5. Now I can clean this up just a touch, because 5x and -x would just be plus 4x minus 5. So that would be this first part, just kind of cleaned up a little bit cleaner version. And then I have a minus here in the middle. So I'm going to copy that down. That's this minus right here. And then I'm going to distribute this x through here. So this will be x times 5x is 5x squared. And then x times 7 is 7x. So when I put these together, I'm just going to combine the like terms, and this is for the top. So x squared minus 5x squared is going to be negative 4x squared. Then I got 4x minus 7x. So 4 minus 7 is negative 3x. And then negative 5 minus 0, no numbers, is just negative 5. So this should be the answer that I get. Another way it could be written is if they multiplied this part out. It'd be negative 4x squared minus 3x minus 5, and then on the bottom they'd have x squared minus x. This should be good. I didn't look at the answer key, but that could be another way it's written. So this one has addition and need common denominator, but I'm going to be a little bit smarter and just factor this out, because if I do that, it's difference of squares. So I'm just going to write the second part as x plus 4 x minus 4. And if I see that, I can tell that the x plus 4, they both have that in common. But what the first part is missing is an x minus 4. So I'm going to multiply the first part by x minus 4 on the top and bottom. Then the denominators will be the same. So if I do that, copy the plus sign down here. So I'm going to do 7 times x minus 4 times 7. So this will be 7 times x is 7x. And then 7 times negative 4 is negative 28. And then on the bottom, it's just going to be x plus 4, x minus 4. Doesn't matter which order. So now they have the same denominator. As long as they have the same denominator, we'll go get the answer here. We just copy that denominator down. I could write it like this also, because we know if we multiply it out, it turns into that. I'm going to do that just so I can sneak it here on the edge of the page. Then you have 7x plus 2x, well that's 9x. And then minus 28 plus, essentially 0, so it's just minus 28. So that would be the answer there for number 14. All right, number 15. Common mistake here, we do need common denominator, but there really is a denominator underneath 7x, it's 1. So if you think about it, you can put a 1 in front of here. So they both have 1 in common, because 1 times anything is itself. But what the first one is missing is it does not have x minus 6. So I have to give it x minus 6 on the top and the bottom, and we're multiplying it. So when we do that, this first one, we're going to distribute. So we'll get 7x squared minus 42x. And then this will just be x minus 6. And then the second part, we'll just copy it down. This will be 2 over x minus 6. So now we have common denominator. We just copy that denominator down. And then I get 7x squared minus 42x plus 2. So that'll be my answer. All right. Number 16. Find all the vertical asymptotes. So I got to factor this out. So I got x plus 4, x minus 4. I should recognize that from the last problem we did. Then on the bottom, they both have a 2 in common. And when I do that, I get 2, and this is x squared minus 4. You could also write that as x plus 4 over x minus 4, and then 2, and then this is difference of squares right here. So this will be x plus 2, x minus 2. Now, the reason why I factored everything out is I just wanted to make sure nothing canceled, because if it did, then I would be worried about a hole, but it doesn't. And the only thing that I'm concerned about is the parts on the bottom that have X in it and what would make zeros inside there. So the number that I would have to stick in for X here to make this part 0 would be -2. So one of my vertical asymptotes, I'm going to write VA for vertical asymptote, is X equals -2. And the other one is going to be what I would put in right here to make this part 0, and that would be +2 minus 2. So that'll be X equals 2. So this one has 2 vertical asymptotes. All right, so in this one, I'm going to factor out using greatest common factor on the top, pull out a 3. So if I pull out a 3, I get x squared minus 4. And from that last one, we'll remember that this will be difference of squares, so we'll get that x plus 2, x minus 2 game going. The bottom, I'm going to try and see if I can factor using box and circle. So I haven't seen box and circle for a while, so I'm going to do it. This is for the bottom. I get 2x squared plus 5x plus 2. So I am looking for two numbers to go in these other boxes that multiply up to 2 times 2, which is 4, and then they add to +5, the middle number. So two numbers that I know that multiply up to 4 would be 4 and 1. So 4x and 1x are just x. So I'm going to put 2x times x. That should give me 2x squared, and it does. And then x times +1, that will take care of this, because x times 1 gives me 1x. And then 2x times +2, so 2x times +2, that should give me 4x. And then just to double check, 2 times 1 gives me +2, so it works. So I could write this bottom part factored as 2x plus 1, and then x plus 2. Now, I'm going to factor that top part out just a little bit more, and I'm going to get x plus 2, x minus 2, and that's using that difference of squares. And then if I look at the bottom, I still have that 2x plus 1 just copying down. But now I realize that these two actually cancel. So that's a hole. The only part that's on the bottom that doesn't cancel is this part right here. So what I need to do is I need to find the vertical asymptote. I need to just figure out what number would I have to put in for x to make this thing right here 0. A cheap way to do that is just say 2x plus 1 equals 0, and then solve for x. So do -1 minus 1, 2x equals -1, divide by 2, divide by 2, x equals -1/2. And that is my answer for my vertical asymptote. So there's only one. All right. Clicking along here, we're at 18. Gonna get up to 25. All right, so the top definitely got a factor, and that's like a big part of the game is factoring. So we're gonna just look at that and believe if I do f of x equals, I'm trying to do it without using box and circle. So multiplies up to -60, but adds to -4. I'm thinking 6 and 10. So you're -10 and +6. I think that's right. And then on the bottom, I can pull out a 3. Now you can use box and circle if you can't do it in your head like I did. That's totally fine. I'm just doing it for time's sake because I feel like you guys won't want to watch me do it. So I pull the 3 out there. I get x minus 10. So it says look for the vertical asymptotes. So if you notice here, this and this are going to cancel. So that's really a hole. So there's no other x's on the bottom. So if I look at vertical asymptotes, there's none. Because there's nothing on the bottom that would make 0 after you cancel out. There'll just be a 3 down there always. All right. Number 19 says find all horizontal. So horizontal is different. Horizontal is always going to be y equals when we get our answer. It'll be a number if it exists. So the thing that I like to do is actually multiply these out. So if I multiply the top out, so I'm going to take it from being factored and turn it into um, the standard form. This will be x times x gives you x squared. Then I'll have x times negative 3, which is negative 3x. 4 times x is 4x. And then 4 times negative 3 is negative 12. On the bottom, put that in here really quick, I'll get 4x plus 10. I'll do 4x times x is 4x squared minus 12x plus 10x minus 30. Now, just to simplify this down a little bit on the top, call it x squared. And I really only care about the x squareds in this type of problem, but it doesn't hurt to simplify and help you guys out with that. Don't really need it here. Putting these two together and then minus 30. So when you look for horizontal asymptote, you want to look for the highest power of x. And the highest power in this whole thing is x squared. And there's x squareds on the top and the bottom. Now, to find a horizontal asymptote, you write y equals, and then you just say, well, how many of the highest power are there on top? So how many x squareds are there? And there's really only one. And there's 4 on the bottom. So the horizontal asymptote will be at y equals 1/4. And the reason is these ones, the x squareds are going to be the ones that get the biggest the fastest. So if you keep putting bigger numbers, you're going to see it keeps getting closer and closer to 1/4, and everything else just kind of drops off. All right, number 20, find horizontal asymptote. So same thing, I'm going to multiply out the top. Now, really, if you think about it, it's going to be 2 times x, that'll give me 2x. And then I'll have to eventually multiply it times x again. So this is going to give me 2x squared and then a bunch of other stuff. And then on the bottom, I'm going to have just 3x. Now, something weird's going to happen here, and minus 3, but if I look at the highest power of x, there's x squared, but there's no x squareds on the bottom. So you got 2 of them on the top, but there's no x squareds on the bottom. And the weird thing is you can't divide by 0. So if you do this, you would say that it's undefined, or you would just say, when it comes to horizontal asymptotes, there's none. They don't exist. If you ever watched Mean Girls, they say the limit doesn't exist. All right, find the horizontal asymptotes for the following. So this one, the highest power of x in the whole problem, it's already multiplied out, is x squared. Now there's no x squareds on the top. You don't see any of them. So for the horizontal asymptote, I'm going to write y equals 0, because there's no x squareds on the top, and then there's 3 of them on the bottom. I don't care about the rest of this. So 0 divided by 3 is just 0, so y equals 0 is the horizontal asymptote. All right, number 22, we're getting close. Find all the holes of the following function. So holes are when it cancels on the top and the bottom. Write your answer as a coordinate point in simplest form. If no hole exists, write none. So got a factor. So I got x plus 1 on the top. On the bottom, this is going to be -5 and +1. So you'll notice this part and this part are going to cancel. Now the number that you would have to stick in to either here or here that would make these parts 0 would be -1, because -1 + 1 equals 0. So that tells me that there's going to be a hole when x equals -1. Now, they said they wanted a coordinate point. So if you want a coordinate point for the hole, coordinates are always going to be x comma y. So I know it's going to be -1. And what you do is you cancel these out. Now, a lot of people say when they cancel it out, they think that there's nothing there. It really divides and turns into the number 1. It doesn't disappear. I mean, anything over itself is 1, so that's where that comes from. And then there's still this x minus 5 part. To figure what the y coordinate is, you just replace x with -1, because that's the value that we want in there. So it's 1 over -1 minus 5, or that would be 1 over -6, or you could just say that's -1/6. So this is the coordinate of the hole. And if you graph it and you in Desmos and you sneak over there, you'll see that that's where there's a hole. 23 says find all holes. We're going to do it again. We're going to factor everything. So I'm going to start with the top. Now something that I notice about the top is everything is divisible by 3. So to be easier on myself, I'm going to pull the 3 out right away. I get x squared plus x minus 12. And then on the bottom, I notice that everything is divisible by x. This will be, I can pull an x out, and then this should be x minus 3. Now I got a little bit more work to do, because that top part, I can do box and circle on this part in here. So this will be 3. Just copying that bottom down. So this would be multiply to -12, but add to +1. So I'm thinking 4, so x plus 4 and x minus 3. So in here, there's a hole, because these two things are the same and they would cancel. So there's going to be a hole when x equals, now to get the coordinates for it, remember, we cancel this part out and write down what's left. So what's left after I cancel it out is 3, and then x plus 4, and then x on the bottom. So what I'm going to do is, everywhere I see an x, I'm going to replace it with the number 3. So if I do that, I get 3 times 3 plus 4 over 3. So 3 plus 4, that's 7. So 3 times 3 plus 4 is 7. So 3 times 7 over 3 is 21 over 3, or just 7. Could have just canceled that out too and just said 7. So there's a hole. The coordinates for it, this is the y value. The coordinates for it are 3, comma, 7. And that's where there's a hole. All right. Number 24 has some graphing stuff. I know most people or a lot of people are getting panicked about this, but remember, if you have Desmos, you can just type things in and find some stuff, but you want to have an idea of where it is before you even graph it, and then you can check. So on the top, I'm going to factor, pull that -2 out. So if I do that, this will be x minus 5, because negative times a negative makes the positive 10. And on the bottom, let's see here, we're going to do, kind of multiply to -15 and add to 2. I'm thinking 5 and 3, and I want this to be negative and this to be positive. So I got x minus 5 and x plus 3. So a couple things that I know. So it says identify all vertical and horizontal asymptotes and x and y intercepts and holes. The first thing I'm going to do is I'm going to look at vertical asymptotes. So I do see that the x minus 5 is going to cancel, but I notice down here that right here, this won't cancel. And x, if it was negative 3, would make 0 down here. So I know right here where x is negative 3, that there's going to be an invisible vertical asymptote. So x equals negative 3. So the graph will not touch that. So that'll take care of the vertical. So horizontal asymptotes, I'm going to use the rule that I did before. I'm going to look at the highest power of x, and I'm going to do that before I factored it, and it's x squared. There's no x squareds on the top, and there's 1 on the bottom, so it's y equals 0. So that means right here, there's a horizontal asymptote at y equals 0. Then I know that if it's an x-intercept, it would be what would make 0 on the top, but there is no 0 on the top, and it makes sense anyway. There's no x-intercepts, and the reason why there's none is because nothing can touch that horizontal asymptote, but also there's no number I could stick in for x that would make this whole top 0. So when it comes to x-intercepts, there's none. That's okay. Now y-intercept, that's when I plug in 0 for x. So it doesn't matter which version I'm going to do it in the original. I can do it in the factored one, but if everywhere I see an x, I put a 0 in there. So that's what I'm going to do. So you go 0 everywhere in here and see what happens. So negative 2 times 0 would be 0. So there'll just be 10 on top. And then on the bottom, 0 squared would just be 0. Minus 2 times 0 would be 0. And then on the bottom be negative 15. So this is going to be 0 when I plug in for x, and then 10 over 15, which would be 2 over negative 2/3. So I'm going to actually draw this thing and see what color I didn't use it, which I'll do it in pink. So at 0, negative 2/3, which would be like right here, there's going to be the y-intercept. So I didn't graph it, but I think it's going to look something like, whoops, like this. And get really close here. And then probably something that looks like this. Now, if I was going to do this for sure, I would just copy this after I did that, and then just take a look on Desmos and see if it works. So what I'm going to do is I'm going to pop over to Desmos real quick, and I'm just going to type this thing in. So here I go to Desmos, and it takes just a second to load. So in here I got y equals negative 2x plus 10, and I'm just going to stick that in parentheses so I can keep it all on top, and then divided by, and I already forgot the other one, what it was on the bottom, so let's pull it up really quick. X squared minus 2x minus 15. Oops. So x squared minus 2x minus 15. And when I look at that, sure looks like I graphed it pretty good, because I'm looking here, there's my 0, negative 2/3. If I type in here y equals 0, it looks for sure like that's an asymptote. It gets really close. If I type in x equals negative 3, definitely looks there like the graph gets really close but doesn't touch. So those pieces look good, and it looks like it's on the bottom and the top. And now I just check that, and that looks pretty good. Maybe it was a little bit tighter, like I'm not as good at drawing, but maybe it was like a little bit like that more, and maybe a little bit more like that. But as far as just having the curve in general, we're okay. I'm going to take a look at the last one here. So it wants to do the same thing. So the first thing I'm going to do is vertical asymptotes. Nothing's going to cancel here, but I am looking at the bottom. So I'm trying to figure out what x would have to be to make that 0. So I'm just going to do 3x minus 7 equals 0. I'm just going to solve for x. So plus 7 plus 7, 3x equals 7. So x should equal 7/3, or that's going to be like, as a decimal, 2.3 repeated. So this is where I think there's a vertical asymptote. So 2.3 repeated would be like 2 and a third. So that would be like right here. So I'm just going to kind of make a little vertical asymptote here. And then I'm just going to put VA x equals 7/3, or it's really, 2 and a third. And then that should take care of the vertical asymptote. If I look at horizontal, I'm looking at the highest power of x, which in this case is just plain x itself. There's 4 of them on the top, and there's 3 on the bottom. So my horizontal asymptote should be y equals 4/3, or that would be like 1.3 repeated. So I'm thinking like 1 and a third. So that's 1 and a third. So my horizontal asymptote y equals 4/3. So that'll take care of that. So then the next part says x and y intercepts. So to find the x-intercept, it should be what makes the top equal to 0, as long as nothing cancels out. So I can definitely do that. I'm just going to do 4x plus 5 equals 0. Solve for x. Minus 5 minus 5. 4x equals negative 5. Divide by 4. Divide by 4. X equals negative 5/4. Or if you like it as a decimal, be negative 1.25. So there should be one at negative 1 1/4. So negative 1.25, that would be like that about. That should be where the y-intercept is, or x-intercept is, sorry. So it would be negative 1.25 comma 0. And then the y-intercept is when I stick in 0 for x. So the y-intercept is when I put 0 in here and see what's left. So 4 times 0 is just 0. 3 times 0 is 0. So I'm just left with 5 over negative 7. So my y-intercept will be at 0 comma negative 5/7. I know there's a negative on the bottom. You can move it up to the top or in front. It's the same. So negative 5/7. See, 0, negative 5/7 is just a little bit shy of 1, so it should look like that. And then when I look at wholes, I don't have anything that cancels out with the top and the bottom, so the answer is there's none. So no wholes. They don't exist. So I think when I look at this graph, you can kind of get an idea of what it is. It's going to get really, really close to this, but not touch. Come through here, get really, really close to this. And then it's also going to be up over here, but not cross those lines. Now to double check it, we could just graph on Desmos and it should work out. Hope that helped for rational functions. Sorry.